Hello, Evergreen. Let's do Chapter 9, Review number 2. So, if you had two polygons, would their perimeters and areas be proportional? Give an example to prove your answer. So, if you had two polygons, would the greater perimeter always also have the greater area? Or vice versa? Well, let's look at some examples. All three of these shapes have 16 units as their perimeter. But as you can see on A, it has 1 times 7. So this area is 7 units and still has a perimeter of 16. And then B also down here has 6 times 2, which is 12 units as its area, and 16 as a perimeter. So as you can see, it's not always the same area if it has the same perimeter. And just doing this vice versa, if we have equal areas, their perimeters also could be different. So this is a 1 by 18 rectangle, and so the perimeter is 38 and the area is 18. And then down here we have 2 times 9, which is 18 for our area, but the perimeter is 22. So perimeter and area are not always indicators that shapes are exactly the same. Number 2, find the perimeter of this rhombus. Write the formula for finding the perimeter first. So a perimeter for a rhombus is pretty simple. It's just the same as a square because all 4 sides are equal. And so we have 4s. And so if we find the perimeter of this rhombus specifically, we have 4 times 5, which is 20 centimeters. Don't forget to put your labels for your answers. Write the formula to find the area of a parallelogram. A parallelogram is base times height. A equals BH. Now remember, it's height, which is the same as altitude, not the side length. So now that we've remembered how to find the area, let's find the area of this parallelogram. Base times height. So this should be 12 times 6, 72. Oops, I should have squared there. Centimeters squared for our area. Write the formula for finding the area of a right triangle. Triangles, as you can remember, are half the size, especially a right triangle, of a square. And so therefore you can imagine it's the same formula for finding the area of a square, except half of it because it is half of a square. So 1/2 base times height. So find the area of this right triangle. So we'd have 1/2 base times height. So 1/2 times 24 times 7, which gives us 84 units squared. Number 7, convert this unit into square inches. So for every foot, so this is 1 foot by 1 foot, okay? And so this is 1 foot squared, 1 times 1 foot squared. If we converted 1 foot into 12 inches, it would be 12 inches times 12 inches, which is 12 times 12, 144 inches squared. Number 8, write the Pythagorean theorem. C squared equals A squared plus B squared. You only have to write this section. And then what is the Pythagorean theorem used for? It is used to find the length of any side of a right triangle, if you know 2 sides. Number 9, explain why this proof helps us understand the Pythagorean theorem. So if we use this right triangle for our example, we have 3, 4, and 5 as our hypotenuse. And we can see that the area of this square, if we made this side of the hypotenuse into a square, would be 5 times 5 is 25. And then on the left, if we use this left leg, 3 times 3 is 9. And if we use the bottom leg, 4 times 4 is 16. And so the area of these 2 legs added together, 16 plus 9, is 25 centimeters. And that is what our formula shows us. It says a squared plus b squared equals c squared. And so a squared, that's the square, plus b squared equals c squared. And it's exactly like we just found out. Find the area of this composite shape. A composite shape is a polygon with two or more shapes within it. And so we're going to find, we could actually do this two ways, but we're going to find the area of the square first, which is 7 times 6, which is 42. And then we can find the area of this triangle, which is 1/2 base times height, 1/2 times 3 times 6, which is 9. And then we add these two areas together, and we have 51 inches squared as our composite area of the shape. Number 11, find the composite area of this shape. So first we're going to find the area of the rectangle, which is 10 times 8, 80. And then we'll find the area of this triangle. So we know the height is 8, and 14 minus 10, the base is 4. And so therefore it's 1/2 base times height, 1/2, 4 times 8 equals 16. We add them together for the composite area, and we have 96 inches squared. Oops, I should say centimeters. Number 12, find the composite area. Now, as we look at this, I can see a triangle, a trapezoid, and I'm assuming a right triangle, but we can't assume, so we'll just say a triangle. And so if we were trying to find this composite area, the simplest way to do this would be to just divide this into a parallelogram and a triangle. That way we only have to find two areas. So to find the area of the parallelogram, we have base times height, so 60 times 30 for 1,800 inches squared. And the area of the triangle is 1/2 base times height, so 1/2, 60 times 40, which gives us 16, oops, should be 1,600. Let me put that on my calculator real quick. Let's see, 0.5 times 60 times 40. Oh, this should be 1,200. This is a mistake. 1,200 inches squared, and we add these two numbers together, 1,800 and 1,200, we get 3,000 inches squared. So we're going to go back to look at number 11, and it says, in this figure, does it follow the area postulate? Explain your answer. Well, we found this by finding the area of the rectangle and then the area of the triangle. This time, let's find the area of the trapezoid, the entire shape. So to find the area of a trapezoid, we add base 1 times base 2, which is 24, and then divide that by 2, which is 12, and then 12 times the height is 8, and so 96 inches. And so since we got the same exact area, finding it separately, adding them together, and finding it as a whole shape, this does prove the area postulate because it says that we could find the sum of the individual non-overlapping shapes and add them together for the total area. And so we have done that. Number 14. Sometimes you don't know, they don't give you the measurements, but instead they show you a polygon on a grid. And so they want us to find the area and the perimeter of this shape. And so it says each small square in the grid has sides of 10 feet. Now, I'm remembering right now that I did not do that. So we have 8, which would be equal to 80 feet. 4, which is equal to 40 feet. And then if we look at this as a rectangle inside of this polygon, we have 40 times 80, or 4 times 8, which is 32. And then add a 0 because it's 32 times 10. And then let's see, when we add 2 more lines, do you see how it creates a square at the top? Yes, and so this has a length of 3, so 3 by 3. So this area is 3 times 3, 9, or 9 times 10, 30, because we have to include this section. Actually, let's just ignore that for now and solve this first. And so therefore, we would have 4 times 8 for the rectangle at the bottom, 3 times 3 for the square at the top. And then this left triangle, we're just going to have to count using the grid. So we have 1 full square and 2 half squares, which gives us a total of 2. And the triangle on the right, we have 1, 2, 3 full squares. We have 2 halves that make us have 4. And then 4 plus 1 half is 4 1/2. And so since we need to multiply this by 10, you would go ahead and do that. 47.5 times 10 would give you 475 feet. Units squared. Okay, now for our perimeter, we already have most of our measurements. We're just going to go back to this little left triangle and we can see that it's 1, 2 units wide, and this right triangle's hypotenuse is 1, 2, 3. And so therefore, if we add all of our sides for the perimeter, we have 8 plus 4 plus 2 plus 3 plus 3, and then plus 4, one more 4 on this right side, and we get 24 units for our perimeter. And if we multiply this times 10, we would get 240 feet as our perimeter. Okay, now we have an angle and we have an array coming out of one of the sides, and it's creating 2 parallel lines. And then we can think of this line as our transversal. Our job is to find the measurements of y and x. And so we know that first, let's find this measurement of this triangle right here. Even though it's not a part of it, let's just kind of use our skills. So we have 180 degrees total in this triangle, then 40 plus 85. And when we subtract these two from 180, we know that this angle is 50 degrees. One thing I also noticed is that x, y, and 50 are a linear pair. And so therefore, if we have 180 minus this 50, we know that x plus y must equal 130. Next, I want to extend my transversal just to kind of see that this angle right here would be 95. 85 plus 95 is 180, and this is a linear pair. And I can see that below my parallel line and to the right of my transversal is x plus 50. Over here, 95 is below my parallel line to the right of my transversal, so I know x plus 50 must equal 95. And so therefore, x is 45 degrees. And now I know, if I'm going back up to here, x plus y is 130, and so therefore 45 plus y equals 130. So y must equal 85. Very good. Okay, find the area of the figures shown below. This is a trapezoid. So we have base plus base divided by 2 times height. 15 plus 25 divided by 2 is 20. 20 times 5, our height is 100 millimeters squared. 17. Find the area of these 2 rectangles. So first I'm going to start with my larger outside rectangle because I already have the 2 measurements and it's just quite easy. 5.6 times 6.4 is 35.84 centimeters squared. Then to find the smaller rectangle, I know that 1.2 plus 0.8 is 2. 5.6 minus 2 is 3.6. And then 3.6 is my bottom number. 3.6 times 5.8 is 22.88 centimeters squared. These are the 2 areas of these rectangles separately. What is the area of this triangle? Now this triangle is not, this is an obtuse isosceles triangle. And we know that the area for a triangle is 1/2 base times height. So we have 1/2, which is 1/2 times 4, the base, times the height is 3.5. This area is 7 centimeters squared. 7 inches squared. Okay, find the area of this trapezoid. Same thing. Base 1 plus base 2 divided by 2, and then times your height, which is 12, you get 300 centimeters squared. Find the missing side length. So we are going to use our Pythagorean theorem. We know this is we don't know this is a right triangle, but I'm telling you this is a right triangle. So we have our formula, a squared plus b squared equals c squared. C is our hypotenuse, which we do not know. So we go ahead and plug in the a and the b. We enter that into our calculator, and we get 29,725 equals c squared. Take the square root of both sides, and c equals 172.41. This time we're going to do it, and we know our hypotenuse, and we are missing one of our side lengths. So we plug in our Pythagorean theorem. We plug in our a and our c. We go ahead and fill all those out. We get 49 plus b squared equals 324. Subtract 49 from both sides. B equals 275. Take the square root of both sides. B equals 16.58. 23. Every polygonal region has a number called its area. Now, areas are always positive numbers. Congruent triangles have equal areas. And the area of a polygonal region is equal to the sum of the areas of its non-overlapping part. Okay, last one. Describe how the altitude of a parallelogram is different from the side length of a parallelogram. So to know this, you just need to know the definition of what the altitude of a polygon is. So the altitude is the height. It is the segment perpendicular to the base. So the key word here is it's perpendicular to the base. It is a measurement that is perpendicular in the height to the base of whatever shape you are looking at. Okay, way to go. I will see you soon. Hope you have a good day. Bye.